On previous note sheets, we've taken a look at the idea that if we want to call two figures congruent, it means that all their corresponding parts are congruent, meaning all pairs of corresponding sides and all pairs of corresponding angles are congruent. And we've been looking at triangles and proving triangles congruent using shortcuts, using shortcut versions of this definition of congruent triangles. The shortcuts have been just proving that triangles are congruent using just three pairs of sides, proving that triangles are congruent using two pairs of sides and the included angle, or proving that two triangles are congruent using two pairs of angles and the included side. Right? And those have been the shortcuts SSS, SAS, and ASA, allowing us to prove triangles congruent. Well, today we're going to look at a couple more shortcuts of proving triangles congruent. And the first one is called angle-angle-side congruence, which is usually abbreviated as AAS. And what it says is if two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of another triangle, then the triangles are congruent. So let's draw this out on our two triangles here. Let's imagine that angle Y is congruent to angle B, right? So angle Y congruent to angle B, that is one pair of angles, right? That's a pair of angles for these two triangles. And let's say that angle Z is congruent to angle A. Angle Z congruent to angle A, that would be another pair of angles. And lastly, let's say a non-included side of one of them. So YZ would be the included side for these two angles. So let's say that XY, that's a non-included side, is congruent to the corresponding non-included side of the others. So the non-included sides that I would have to pick from would be AC and BC. But which one corresponds to XY? It's BC, right? It's obviously the shorter of those two. So the corresponding non-included sides that are congruent are XY congruent to BC. And there's our other pair of sides. So this is what angle-angle side would look like in a picture. Two angles and a side that's not between them, congruent to two other angles and the corresponding side that's not between those. And that's angle-angle side. The other one that we're going to learn about today is called hypotenuse leg. And the fact that it uses the word hypotenuse should indicate that we're talking about only right triangles, because right triangles are the kinds of triangles that have a hypotenuse in them. So hypotenuse leg, or HL, says if the hypotenuse and a leg of one right triangle are congruent to the corresponding parts of another right triangle, then the triangles are congruent. So if we're going to use hypotenuse leg, first of all, we got to make sure we're looking at two right triangles. So angle G is a right angle and angle M is a right angle, so I have two right triangles here. Now the first thing that has to be true is the hypotenuse has to be congruent on each triangle. Now the hypotenuse is always the side across from the right angle, so that would be segment HF and segment NL. So we'll say that HF is congruent to NL, and that's the hypotenuse, the H part of HL. And then we have a leg from one triangle congruent to a leg from the other. So in this case, I'm going to mark that FG is congruent to ML, and that satisfies the leg part of HL. So that would be what we would be looking at if we were going to use HL. Two right triangles, hypotenuse is congruent, and one of the legs congruent on each. And that gives us HL. So that now completes the five shortcuts that we can use for saying that triangles are congruent, right? We now can use side, 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 angle, side, angle, side, angle, 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 side, and HL, right? And remember that ASA and AAS are different, even though there are two A's and one S in each. They're different because in ASA, it's the included side, and in AAS, it's a non-included pair of sides that we have. So let's look at these three examples and decide if we're looking at congruent triangles. In part A, you'll notice that we have two right triangles. So I can maybe think about HL being a possibility. But let's look at what we have as congruent. Let's see if it is HL, or if maybe it's one of the others, or maybe it's none of them. I know that I have angle A congruent to angle D, which would be a pair of angles that are congruent. Right? They're right angles, so they have to be congruent to each other. I also have angle ACB congruent to angle DBC. So that's another pair of angles. Lastly, I have this shared part, segment BC, that would be congruent to itself. So that's a pair of sides. So now I have to ask myself, okay, it looks like I have two pairs of angles and a pair of sides, which would kind of narrow it down to maybe angle, side angle, or maybe angle, angle, side. So I just have to figure out, is this right here, is it included between these angles or non-included? And if I look at my picture, I can see that that is a non-included side for these two angles. It's across from the right angle. And it's a non-included side for these two. It's across from the right angle. So that means that triangle ABC is congruent to triangle. Let's see if I called it ABC. It looks like I got to call it DCB by angle, angle, side, because I'm looking at a non-included side. Why isn't it HL, even though I'm looking at two right triangles? Because all I have is the H part, right? This segment BC congruent to itself could be considered the hypotenuse of my right triangles, but then I don't have the leg part. I don't have another pair of sides that would be legs of my right triangles. So HL doesn't work in example A. In example B, let's look at what I have. I have that AB is congruent to, that's kind of a sloppy congruent sign, is congruent to segment AD. So that would be a pair of sides. I have that angle ACB is congruent to angle ACD, right? These angles right here are congruent. So that would be a pair of angles. And then I have the reflexive property that would give me segment AC congruent to itself. So that's another pair of sides. And that's all I have that I know would be congruent in this picture. So now I have to evaluate. If I have two pairs of sides and one pair of angles, the only one that might be available to me is SAS. So I got to check, is my angle pair, is it the included angles? And in this picture you can see that if these are my two sides, the included angles would be right here and right here. But I don't have that those are congruent. I have a different pair of angles. So what I have to say, because I don't have any SSA, like I have AAS, there is no SSA, I have to say in this problem that no congruence can be determined. Maybe these two triangles are congruent, but I can't prove that they are based on the information that I have. In example C, again, I have two right triangles. So I might be thinking that HL is a possibility. But I also have a pair of sides here. So let's say we have angle EGF that would be congruent to angle JGH. So that is a pair of a pair of angles, and it also opens the door for hypotenuse leg because they're right angles. And then I have segment EF congruent to segment HJ, which is a pair of sides, but it's also, you'll notice, those are also the hypotenuses of the two right triangles. So I can maybe say that that's also my hypotenuses. Then do I have anything else? Is there anything else in this picture that's on my watch out for list of things that could be congruent? Well, some people might think I have shared parts because these triangles are kind of back to one another, but I don't really have shared parts. I have HG congruent to itself, but HG is only a part of this triangle over here on the right. I could say that EG is congruent to itself, but EG is only a part of the triangle that's on the left. So even though they are kind of back to one another, they're not sharing any complete sides or any angles, right? They're sharing part of a side, but not any complete sides. So this looks like all I have. I have one pair of angles, one pair of sides, or just the hypotenuses if I'm looking at HL. So on this one, I also have to say that no congruence can be determined. No congruence can be determined.